Welcome back to the video, guys. In this video, we'll be discussing question 4, 5, 6, and 7 of activity 2.1, which is based on determinants. So let's get started. Here in the question 4, it is given to us that there is a matrix of order 3 cross 3 where A plus B plus C is divisible by 6. Then choose the set of correct options. So what we can derive from this? If it is given to us that A plus B plus C is divisible by 6, then it means it could be represented in the form of 6 times K, where K is some constant. So now moving on to our matrix. So determinant of A is just determinant of A, B, C, B, C, A, and then C, A, B. So what I'm going to do here is I'll just do this row operation where I'm adding row 2 and row 3 to my row 1. So what would happen now? It would give me A plus B plus C, then B plus C plus A, which is again A plus B plus C, and then C plus A plus B, which could again be written as A plus B plus C. And rest of the rows will remain same, B, C, A and C, A, B. Here if I take uh, A plus B plus C common from the row 1, I will get A plus B plus C times of some determinant. So I'm writing the value of rest of the determinant as this delta. So here I can see that A plus B plus C was already divisible by 6. So this could be written as 6 times K times delta. So the conclusion that we have drawn from here is determinant of A is equal to some 6 times of constant. That means determinant of A is divisible by 6. So if determinant of A is divisible by 6, then it means it is automatically divisible by 2 and 3 as well. Why? Because any number that is divisible by 6 is also divisible by 2 and 3. You can take 36 as an example. It is divisible by both 2 and 3. So hence option number 2, 3, and 4 are correct. But there is no such proof for option number 1, so we are marking it as incorrect. Okay. Moving on to the question 5, here it is said that A is a square matrix of order 3, which is defined as this. Aij is equal to I. So let's try to write the matrix. So A11 would be 1, A12 would be 1, and A13 would be 1. That is, all the elements of row 1 would be 1. All the elements of row 2 would be 2. 2, 2 is also 2, and A23 is also 2. And what about the elements of row 3? So obviously they're going to be all 3. So A32 is 3 and A33 is 3. So we have the matrix with us, that is 1, 1, 1, 2, 2, 2, and 3, 3, 3. It is asking us the value of determinant of A. So to find the value of determinant of A, maybe we can do a row operation here where we will do row 2 minus 2 times of row 1. What will happen in this case? We will get our matrix as 1, 1, 1, 0, 0, 0, and 3, 3, 3. So since we have a 0 row over here, we can deduce that determinant of A is equal to 0. So the answer here is 0. Moving on to the next question, that is Aij is denoted matrix A denoted as a matrix of delta Ej, where delta Ej could be expressed as this I times j. So what about delta 1, 1? It is just 1 times 1, that is 1. Delta 1, 2 is 1 times 2, that is 2. And delta 1, 3 is 1 times 3, that is 3. What about delta 2, 1? Delta 2, 1 is 2 times 1, 2. Delta 2, 2 is 2 times 2, 4. Delta 2, 3 is 2 times 3, 6. Delta 3, 1 is 3. Delta 3, 2 is 6. And delta 3, 3 is 9. So here I can write my A as 1, 2, 3, 2, 4, 6, and 3, 6, 9. Okay, so here again I can note something very interesting, that from row 3, if I subtract 3 times of row 1, what I will get? I will get 0, 0, 0 over here, and rest of the rows will remain unchanged. And yes, again, since I have obtained a 0 row over here, so the value of determinant of A is going to be 0. So again, the answer of this question is 0 as well. Quickly moving on to the question 7 that says A, B, and C are three different matrices and we have to select the correct set of options. So uh, how can we go from A to B? So A is this, B is this. So here we can observe one thing that this is our row 1, this is our row 2, and this is our row 3. So if we just exchange row 1 and row 2, so in the matrix A, if we interchange row 1 and row 2, we will obtain matrix B. And we have seen if you interchange a row with another row, so what happens to the determinant? It gets multiplied with -1. So that means determinant of B could be expressed as minus of negative of determinant of A. Okay, so uh, option 1 is incorrect, whereas option 2 is correct. Okay, uh, now moving on to the next part, which talks about determinant of C. So here, how can you go from B to C? So see, you can observe that row 2 and row 2 are same, row 3 and row 3 are same, but uh, in row 1 we have just multiplied each and every element with 2. So that means if you go from B to C, what you need to do is you just need to multiply your row 1 with 2. So that means if you multiply each and every element of your row 1 with 2, you will obtain C. So what happens if you multiply a particular row with a constant? The value of determinant of the matrix gets multiplied with the same constant. That means uh, the determinant of C could be expressed as 2 times of determinant of B. So option C is correct, that it is not equal to minus of 2 times of determinant of B. And since determinant of B was equal to minus of determinant of A, that means we can also express the same thing as 2 times of minus of determinant of A, that is minus of 2 into determinant of A. So option 4 is also correct. So this was all about question 4, 5, 6, and 7. Let's see you in the next video where we'll cover question number 8, 9, and 10. Till then,